Hey guys, this is Kausip. Today we'll explore the key differences between three common types of cables used in data transmission. Those are twisted pair cable, coaxial cable, and fiber optic cables. Let's jump into the introduction. To begin with, let's understand why choosing the right type of cable is crucial in networking and data transmission. In today's truck-driven world, cable selection is critical for smooth data flow. Think of our networks as body circulatory system, cables as arteries and veins. Choosing the right cable is like selecting the right vessels for efficient blood circulation. Mismatched or choosing wrong type of cables can impede data, causing bottlenecks, signal loss, and data corruption. Now, let's see each cable one by one. The first type of cable we are going to discuss is twisted pair cable. Twisted pair cables are a type of electrical cable used in telecommunications and networking. Twisted pair cables consisting of pair of copper wires twisted together, as you can see in the image. They are the most common type of cable used for Ethernet connections. Now, let's see the main characteristics of twisted pair cables. Those are noise reduction, types, versatile, cost effective, limited distance, data rates, easy installation. Let's discuss them one by one. First, noise reduction. Twisted pair cable reduce electromagnetic interference and radio frequency interference. Types. Twisted pair cable comes in two types. Those are unshielded twisted pair and shielded twisted pair. UTP is widely used, while STP provides additional shielding for extra protection. Third, versatile. Twisted pair cables are incredibly versatile. They can handle data, voice, and multimedia transmission, making them suitable for various applications. Cost effective. These cables are cost effective, which is why they are a popular choice for networking. They offer good performance without breaking the budget. Distance limited. Twisted pair cables are best suited for short to medium range connections. They are perfect for networking within homes and offices, but not for extremely long distances. Data rates. Twisted pair cables support various data rates based on their category. For example, Category 6 and Category 6A. Higher category cables can handle higher data speeds suitable for modern high-speed networks. Easy installation. Installation is straightforward because of their flexibility and standardized connectors. RJ45 connectors commonly used in Ethernet make setup easy and consistent. Let's discuss second type of cable. Those are coaxial cables. Coaxial cables are the type of electrical cable that consisting of a central conductor, an insulating layer, a metallic shield, and an outer insulating layer. They are also called as coax cables. Coaxial cables are known for their concentric design. They are widely used for cable television and some internet connections. Coaxial cable was invented in 1880 by English engineer and mathematician Oliver Heaviside. Let's discuss the primary features of coaxial cables. Those are central conductor. The first thing is central conductor. The central conductor carries the actual signal. Think of it as a highway for data transmission within the cable. Second, the insulating layer. This layer is like a protective barrier around the central conductor. It prevents electrical interference and signal loss. Third, metallic shield. The metallic shield is like a suit of armor for cable. It blocks external interference, ensuring a clean signal inside. Fourth, outer insulation. The outer insulation adds an extra layer of protection. It also helps maintain the cable's physical integrity. Fifth, impedance matching. Coaxial cables are designed within a specific impedance, for example 50 to 75 ohms. This design ensures that signal flows efficiently, reducing reflections. Sixth, high bandwidth. Coaxial cables can handle a wide range of frequencies. This high bandwidth makes them suitable for transmitting cable TV, internet, and more. Seventh, applications. Coaxial cables find use in diverse applications. They are vital for cable TV, broadband internet, CCTV systems, and data communication networks. Eighth one, signal quality. Coaxial cables maintain the quality of audio and video signals. This ensures sharp and clear transmission of information. Durability. These cables are built tough. They can withstand environmental conditions, making them reliable for outdoor and indoor use. 10th, the connectors. Coaxial cables use various connectors like F-type, B and C, and N-type. These connectors ensure secure and dependable connections. Let's discuss about fiber optic cable. Fiber optics or optical fiber refers to a technology that transmits information as light pulses along a glass or a plastic fiber. A fiber optic cable can contain a varying number of these glass fibers. Fiber optic cable are commonly used because of their advantages over copper cables. Some of those benefits include higher bandwidth and transmit speeds. Fiber optics is used for long distance and high performance data networking. It is also commonly used in telecommunication services such as internet, television, and telephones. Now, let's see the unique characteristics of the fiber optic cables. First, light-based transmission. Fiber optic cables transmit data using pulses of lights. Think of it as sending information through beams of light. Second, immunity to EMI. Unlike copper cables, fiber optics are immune to electromagnetic interference. This means data remains secure and reliable even in noisy environments. Third, high bandwidth. Fiber optics offer a vast data highway with exceptional bandwidth. They can handle large data volumes, ideal for modern high demand applications. Fourth, low signal loss. Light signals in fiber optic experience minimal signal loss. This allows data to travel over long distances without degradation. Fifth, long distance. Fiber optics can transmit data across vast distances, often spanning kilometers. No need for signal boosters or repeaters. Security. Fiber optic data is challenging to intercept or tap. Its light based nature and lack of detectable radiation enhance security. Thin and lightweight. Fiber optic cables are slender and lightweight. They're easy to handle, install, and do not add bulk to installations. Immunity to crosstalk. Unlike copper cables, fiber optics do not suffer from crosstalk. Data remains isolated, ensuring signal integrity. Environmental resistance. Fiber optics are resilient against moisture, temperature changes, and corrosions. They maintain reliability even in harsh conditions. Diverse applications. Fiber optics find use in various sectors including telecommunications, internet, healthcare, and military communications. They are versatile and adaptable. Future proof. Fiber optic technology continues to advance. It provides a forward looking solutions for evolutionizing data transmission needs. Here's a comparison of the bandwidth capabilities of the three cables: twisted pair cable, coaxial cable, and fiber optics cable. Twisted pair cables. Twisted pair cables like Category 6 and Category 6A offer decent bandwidth. They can handle data rates up to 1 Gbps or even 10 Gbps but over shorter distances. Best suited for moderate speed local area networks, or also known as LANs, and shorter connections. Coaxial cables. Coaxial cables provide higher bandwidth than twisted pair cables. They support data rates ranging from 10 Mbps to 1 Gbps, commonly used for cable TV and broadband internet, delivering ample bandwidth for multiple TV channels and high speed internet services. Fiber optic cable. Fiber optic cable offers the highest bandwidth capabilities among the three. They handle extremely high rate data rates ranging from 10 Gbps to 100 Gbps or even more. The preferred choice for ultra fast internet, data centers, and long distance telecommunications due to their ability to transmit large volumes of data quickly and reliably. While the twisted pair cables provide decent bandwidth for local networks, coaxial cables offer higher bandwidth suitable for cable TV and broadband internet. However, when it comes to the most demanding application requiring the highest bandwidth, fiber optics cables are the clear winners. Let's discuss the maximum transmission distances for each cable type: twisted pair cables, coaxial cables, and fiber optic cables. The first, twisted pair cables. Twisted pair cables have limited maximum transmission distances. Typically, they are restricted to 100 meters. Beyond this limit, you may encounter signal degradation and data loss. Ideal for local area networks in homes, offices, and small to medium-sized buildings. Second, coaxial cables. Coaxial cables offers extended maximum transmission distances when compared to the twisted pair cables. In applications like cable television and broadband internet, they can reach up to 500 meters, even without signal boosters. However, the exact distance can vary based upon the cable type and the quality. Suited for distributing TV signals and high-speed internet within residential and commercial buildings. And the last, fiber optic cables. Fiber optic cables are renowned for their remarkable maximum transmission distances. They can transmit data over exceptionally long distances, often spanning kilometers or tens of kilometers, without signal degradation. The actual range depends upon the type of the fiber and network equipment. Crucial for long-haul telecommunication networks, including global and undersea connections. Also suited for converging extensive distances within large data centers and corporate campuses. So basically, twisted pair cables are suitable for relatively short distances within buildings. Coaxial cables offer longer transmission ranges, especially for cable TV and broadband, while fiber optic cable excel in providing a reliable data transmission over vast distances, making them indispensable for longer haul telecommunications and high-speed internet backbones. Let's see how each cable type handles interference. Twisted pair cables. Twisted pair cables employs a technique called twisting of wire pairs to combat interference. Pairs of copper wires are helically twisted together. This twisting action encounters electromagnetic interference and radio frequency interference. When electrical current flows, this twisted pair's magnetic field cancel out each other, reducing the interference. An insulating layer adds an extra shield against the interference. Coming to the coaxial cables. Coaxial cables are inherently effective at handling interference. They feature a layered design within a central conductor insulating material, metallic shield, and outer insulating layer. The metallic shield acts as a barrier to the external electromagnetic interference and radio frequency interference. It also confines and reflects signals within the cable, minimizing signal loss and external interference. Coaxial cables excel in applications like cable television, where multiple TV channels are transmitted without interference. And last, coming to the fiber optical cables. Fiber optic cables are exceptionally resistant to interference thanks to their unique transmission method. They transmit data using light pulses which are impervious to electromagnetic interference and radio frequency interference. Light is not affected by the same electrical phenomena that affect copper-based cables. Fiber optics are entirely immune to these forms of interference. In summary, twisted pair cables mitigate interference through twisting and insulating the wire pairs, where coaxial cables rely on their layered design and metallic shields. However, coming to fiber optic cables are the most effective ones at handling the interference because they use light signals which are impervious to electrical interference, offering a high degree of immunity and signal integrity. Now, let's discuss about cost and applications. Cost effectiveness and common applications of each cable type. The first, twisted pair cables. Twisted pair cables are the most cost effective option among the three cables. They offer budget friendly solutions, reliable availability in the market. Common applications of twisted pair cables are local area networks, are also known as LANs, telephone systems, residential networking. Coming to coaxial cables. Coaxial cable falls in between the cost spectrum, being more expensive than the twisted pair cables, but generally more affordable than the fiber optic cables. The actual cost varying depending upon the specific type and the quality of the coaxial cable. They strike a balance between the cost and the performance, making them suitable for a wide range of applications. Common applications of coaxial cable are cable television, broadband internet, closed circuit television, also known as CCTV, and amateur radio. And the last, fiber optic cables. Fiber optic cables are the most expensive among the three cable types, primarily due to their cost of their optical components. While initial installation costs can be higher, they can offer significant cost savings in the long-term maintenance. Their resistance to signal loss and reduced need for replacement to contribute to a long-term cost effectiveness. Common applications are telecommunications backbone, data centers, high-speed internet, military and aerospace applications, medical imaging, etc. In summary, each cable type offers effectiveness in its own way, making them suitable for various applications. Twisted pair cables are cost-effective for local networks, coaxial cables balance cost and performance for TV and internet, while fiber optic cables are chosen for high-speed and interference-resistant applications, despite their high initial cost. In conclusion, understanding the characteristics and applications of different cable types and selecting the right cable for specific needs is essential for seamless data transmission and the success of modern networking and communication systems. Each cable type has unique characteristics, advantages, and limitations. Twisted pair cables are suitable for moderate speed local networks. Coaxial cables are ideal for applications like cable TV and broadband. Fiber optic cables are indispensable for high speed and long distance data transmissions. That's it. And that's the end of the video. Thanks for the watch.